During the Second World War, aeroelasticity, a new field of study, enters the design of aircraft. The Reggiane Re 2005 was one of the first aircraft to be involved in these complex issues. The Reggiane Re 2005, during the tests on the prototypes, the first complained of the problems with the fairing and the undercarriage at high speed above 900 km/h. The depression which was created on these structures at these speeds was sufficient to generate so much problems as to make the truck out of its seat in the right around at a speed of 900 km/h. If a small deformation was generated on the fairing of the trolley, disorders in the lateral balance and consistent vibrations were immediately triggered. Furthermore, if the steering wheel was not perfectly balanced, it should be remembered here that the Reggiane Re 2005 was an aircraft which arrived sinking at speeds near, if not equal to 1000 km/h. But it was so well designed that it was easy to disengage the vibrations by changing the setup OR the round per minute. Unless if you are at speeds of 900 km/h or even higher, where these corrective maneuvers which disengaged the vibrations were very difficult to implement. Even more if it was in an operational field, where the escape and fighting maneuvers means that the stress limits were consistently exceeded and triggered serious problems on the structure of the aircraft, particularly in the tail. The slim aerodynamics of the Reggiane Re 2005 allowed to achieve these very high speeds when sinking, even if the weight of the aircraft was not in itself consistent. The only Allied aircraft which could have stayed in the tail of the sunken Reggiane Re 2005 was the P-47, which was not operative until August 1943. At least 1943 in the European chessboard, and above all it was little maneuverable and immensely leakers at dogfighting. But it should be pointed out how the problems of flutter and in general all the problems of aeroelasticity were, in 1943, at the top of the technique, and all the powers were seeking empirically and with continuous tests in the wind tunnel and on aircraft to obtain that set of information which allowed to screw and validate the various theories that had developed about these complex phenomena. Linearized theories were still used for the calculation of aeronautical structures, phenomena which moved on the limits between the subsonic field and the supersonic field, where the turbulences, the structural deformations induced by energy exchanges, were strongly entering the field of nonlinear fluid dynamics, generating force fields and excitation of elastic motions with very large levels of energy transmission. Fields and motions that could assume in times of thousands of a second trends that were not manageable by human reaction and by the structures which were used in the 1940s, which, in the great most cases, were not conformed to have large damping factors when it was at the limit of the subsonic field. In this respect of the Reggiane Re 2005, experienced test driver De Prato reported that for this aircraft had never noticed sudden hurting phenomena, and that in progressive tests conducted the appearance of exceptional phenomena, even in rapid development, were definitely foreseen by one perceptible pilot sensations an expert experimenter. This witnessed the extreme knowledge of the Reggiane design team. Instead, at the maximum speeds achieved, he had observed a threading widespread throughout the aircraft, presumably caused by aerodynamic phenomena which developed on the wing surface. These vibrations were reduced in amplitude and increased in period. Commandant De Prato said that they were comparable to those that the common stall induces. In any case, all the changes were made with similar times to those recorded on aircraft with similar Allied and German problems. Therefore, by now, at least as regards the operational performance of the aircraft, the Italian industries at the end of 1942 were on the standards of other foreign companies or even higher. The analysis of the Reggiane Re 2005 and the Fiat G55 shows this. The pain point was the reduced industrial capacity aggravated by the further reduction of the flow of raw materials and the destructive bombing against industrial factories and infrastructure. In any way, the structural corrections carried out both as regards the fuselage at the tail, and as regards the wing surface, and as regards the plating, were fully successful. As for the flutter slips near 1000 km/h, the flight envelope was simply adjusted by recommending the pilots not to exceed speeds of 900 km/h when sinking. All of this generated an airplane of excellent qualities which demonstrated in the operational field already from April 1943. As it was at the top of the technology in the world field, with the comparisons made on the interceptions from Naples Capodichino of the bombers and Allied fighter escort formations.